Let's talk about doing stoichiometry with solutions. As we may remember, stoichiometry was that process of determining how much of one reactant we would need to react with others, or how much product we would make for certain reactants, or vice versa. And we kind of followed this pathway of starting with mass of compound A, whatever it was. We would use its molar mass to get the moles of A. We would then use the reaction coefficients from our balanced equation to get the moles of B, and then we could use molar mass to get the mass of B. So that was how we went from mass to mass. But now we're going to introduce two more kind of prongs to this. Now with molarity, we're going to be able to go from moles of A to volume of solution A, or from moles of B to volume of solution B. And that would be using, light blue here, the molarity of solution A and the molarity of solution B. The molarity tells us a conversion factor between moles and liters of solution, right? Molarity is moles per liter. Molar mass is grams per mole. So we're able to get these conversion factors that get us to be able to switch between different quantities. So we can now use the mass of A, find moles of A, go to moles of B, and then find volume of solution B instead. Or we can use volume of solution A to find mass of B, or volume of solution B. So this, all of these are backwards and forwards arrows, because we can use them to figure out any other quantity we're looking for. Let's say, for example, if I mix, how about 125 milliliters of calcium chloride. We should put a molarity with that. Let's say it's 1.24 molar calcium chloride. With excess, and I'm just going to use excess here so we don't have to do a limiting reactant, but sometimes you may need to. Just be aware that if I don't say excess explicitly, you're going to have to do a limiting reactant, meaning you have to do it twice. All right, so if I use that with excess sulfuric acid, what mass in grams of calcium sulfate is produced? So, step one for this is we have to actually write an equation, a chemical equation. So I want you to pause the video and write the chemical equation and balance it. All right, so you should get calcium chloride plus H2SO4 turns into a CaSO4 plus 2H2O. Nice and simple equation for us. Notice the calcium sulfate is solid. We have aqueous reactants here. All right, so in this case, we're going from some concentration and volume of calcium chloride, and we're looking for mass of calcium sulfate. So if we were to go back up to our kind of scheme here, in this case, we have volume of solution A, that's 125 milliliters. We're looking for mass of component B, whatever it may be. So we're going to follow the pathway that leads us there. We're going to go use the molarity of A to go to moles of A, calcium chloride in this case. We're going to use our reaction coefficients to turn that into calcium sulfate, and then we're going to use the molar mass of calcium sulfate to calculate the mass of B. All right, so now that we have that, we're going to want to use the molarity. Molarity, however, is moles per liter. We don't have liters here, so we'll just immediately fix that. There we go. Problem solved. Going from milliliters to liters should be something you can do in your head. It's a very simple calculation, divide by 1,000. That's all you got to do. So with that in mind, we can go ahead and do this. So we have 0.125 liters of calcium chloride. And again, I like to make sure we indicate what component we're dealing with at each stage, so we are completely correct with our units. All right, doing this, we have our moles per liter. We want liters to cancel out, so liters are going to go on the bottom. Remember, molarity is moles per 1 liter, so we're always going to have 1 liter on the bottom there. 1.24 moles. That's not a 4. And this is all CaCl2. We need our reaction coefficients. They were both 1. The 1 mole of calcium sulfate. And then lastly, we're going to need the molar mass of calcium sulfate, the CaSO4, which we should calculate because I hadn't done that beforehand. So we've got 40 plus 32.07 plus 4 times 16. So that's 136.07, assuming I've got the numbers correct. Double check me on that. And so we can go ahead and now do the calculation. So everything's the same. We've just switched our way of getting to moles of A. In this case, we're using a volume and molarity instead of mass and molar mass. But it's all the same. So 0.125 times 1.24 times our 136.07, and we get 21 point, how many sig figs? Looks like 3 sig figs here. 21.1 grams of calcium sulfate is produced. So we can do that. We can also say, all right, assuming 100% reaction, which generally these are, what volume, let's say we're using 0.75 molar H2SO4 was required. We could figure that out as well. So let's say instead now we're looking at the sulfuric acid. So, now that the excess is out of the way, let's see how much we would have used. And so we can do the same thing. We can say, okay, well, I know the amount of calcium chloride I'm reacting. So I have volume of solution A. And in this case, instead of going to mass of B, I have a molarity and I want to see what volume I need. So in this case, we're going to just do the following. I'm going to have a little rainbow here. We're going to go from volume of solution A, use its molarity, get the moles, convert to the moles of sulfuric acid, and then use the molarity of the sulfuric acid to find the volume. So it's all, whichever pathway you take depends on what you're given and what you're looking for. In the last case, we were looking for a mass, so we ended with mass of B. In this case, we're looking for a volume of solution B. So that's what we're going to use. So everything else can stay the same. Let's start up the same way. 0.125 liters of calcium chloride times 1.24 moles of calcium chloride per liter calcium chloride. We have our reaction coefficients, which I believe were both 1. Yep. 1 mole calcium chloride, 1 mole sulfuric acid. And then we have our molarity. In this case, we're looking for the liters, so we want the liters on top. And we have our molarity, which was, it was 0.75. So that number is the moles, right? That's how many moles in 1 liter of sulfuric acid. And so doing all of this, bust out thy calculator again, 0.125 times 1.24, divide this by 0.75, and we get 0.206 liters, 207 I suppose with sig figs, or since I didn't specify a unit, shame on me, we would say 207 milliliters. That would be another acceptable answer. So either of these would work. That would be the amount of solution required to do that reaction. All right, so it's really just adding one more little bit to our toolkit of stoichiometry. And later on in chapter 10, we'll add a third prompt to this. So don't forget this even as we go through some of the more conceptual chapters. All right, the last thing I want to point out is if you are calculating molarity, if you are calculating the molarity, what you want to do, it's a little bit hard because you're solving for a conversion factor. So you want to remember the formula of molarity, which is moles per liter, right? Typically, if you're calculating a molarity, that means you already know your liters. That's typically known. Because the way you do this is you'll do what's called the titration. This is something to be covered in lab. And the titration is something that you are going to figure out the volume needed to react. And from that, you're going to calculate the moles. From the moles, then, once you know your moles and your volume, then you can find the molarity. So this is calculated using stoichiometry. So for example, I'm just going to give us some data. If 22.40 milliliters of 0.1234 molar NaOH needs 16.22 milliliters of HCl to fully react, what is the molarity of the HCl? That's the context of this. And this is, again, a very common experiment in chemistry, to find the unknown concentration of whatever you're looking for. So we can use stoichiometry. We have this known volume then. We have our 16.22 milliliters. That's our volume of HCl. And in order to find molarity, we need the moles of HCl and the volume of HCl. We don't know the moles directly, so we have to use stoichiometry. So I want you to try this, and we should see what you get. So you want to start with your 22.4 milliliters of NaOH, and you should be able, from this information, to be able to find out the moles of HCl. From there, once you have this volume and the moles, you use your equation, moles per liter, and you will get the molarity. All right, so it'll be in the notes. I'll have the answer, so go ahead and pull up the notes, and you should see the answer, and hopefully you've gotten it.